and implement it into our workflow. So I have 30 minutes with you today. I'm gonna try to get through this in 20 and give some time for some question and answer session at the end. I'll take a peek in case we get some raised hands or some notes, but I really want to set aside some time so I can focus solely on you guys' questions and get anything answered. So we're going to start off with quick slides. I'm going to go pretty fast because I want to do some live. I know it's kind of dangerous on these webinars, but I want to do some live work with you guys in the software, as well as a live demo of the whole Zebris process. So first off, the Zebris, where it falls in the workflow is at the very beginning. We have all of these things, all of these steps in CAD/CAM that have been improving with technology. But it just seemed like at the very beginning, we're missing that step. And I'm excited when we added this to our portfolio because we can have all the accuracy in the world, but if the patient's actual movements and actual positioning are not correct, then there will be adjustments. No matter what we do in the process, no matter how perfected and consistent your process is, if we can't replicate what's in the mouth and the movement in the mouth, there will be adjustments. That's just inevitable. So that's where it fits. These are the pieces of the Zebris. We have our head bow, we have our sensor, what you see next to it is the stand that it sits on. It's actually its charging base. So this Zebris can be connected direct and as well as wireless. So in the software, this is where the magic happens. So it's not just Facebook placement. It is recording the jaw movements and giving you individualized articulator settings that you can transfer to your design software. For Ceramill, so it's our workflow. It is really transferring that data. So the doctor takes the Zebris Facebook, gets all that data and can electronically email that file to the lab. They can input that into our software, and instead of a virtual articulator, we have a virtual representation of the actual movement. So once I get in there and start designing, I'm going to show you the difference between articulated movement, which is more linear, and jaw movement, where you'll actually see opening, closing, and chewing of the patient in the software. So again, this is how it fits. So whether it's a lab scanner or an intraoral scan that's taking the upper and lower, we can still integrate that into our workflow with the movement that transitions into the design software to the actual virtual articulator. And then we even have the ability, as you see at the last step, to bring that back and mount that on our articulator to verify. So in the whole grand scheme of things, we have CAD. That's what's in the middle. But if you look at all the other pieces, you have intraoral scan, model scan, face scan, but we're bringing function, true function, not just the function as the upper and lower relate to each other, but how the upper and lower move and how it fits in the face in reference to the condyle. So tying all that together, we'll come out with better product, less adjustments, more accurate, because we have that representation of what's going on in the patient's mouth. So we also, let's say this is a standalone. So if we have a doctor on the other side of the country that can take this information, send it to a lab, they can still print and mount these models and scan it. So we're very flexible in how we offer this to our customers. And again, this is showing, and I'll show you in the software how we can bring this back and mount this on an articulator and get that positioning. We also have a digital dynamic occlusion analysis. So traditionally in CAD/CAM, it's always, where's my interferences? What's exciting about this is you can analyze and say, you know what, during the patient's natural movement, where are they coming into occlusion? Where's the static occlusion? Where's dynamic occlusion? To me, that is critical because not everybody bites down perfect and symmetrical. So having this dynamic analysis gives us another tool in that CAD/CAM toolbox to be able to produce an accurate restoration. Again, tying that into wear analysis. So let's say if I'm doing a splint or anything, I can look and see where they're actually wearing that teeth, those opposing are wearing during chewing movements. I was going to show this video, but like I said, I'm really excited about showing you these steps. So I'm going to focus more on the actual software and show you the software. So let's close this. And on my screen, I'm going to bring up the Zebris software. And then at the same time, I'm going to be doing the movements. So I'm going to be wearing the Zebris. It looks like a face bow, but it's all wireless. There's no, or it's just everything. We have sensors up under here that's going to record everything. I don't know if you guys can see this clearly, but once I start designing, once I start moving, you'll see this simultaneously, me moving and actually the software recording those movements. So I'm going to go and do a new patient. This is the database for this. We're going to call it LMT. That's going to be my first name today. And male and date of birth. And we're going to select OK. So now I'm going to go to measure. Actually, let me show you. I want to show you this really quick. So in the software, you can select different, let's say you had different rooms, different treatment rooms. You can actually set up this in multiple rooms and just transfer, walk this over to the next room and you're ready to go. You don't have to, restart all the equipment or move the equipment. You have your Zebris, you have your computer, whether it's on a laptop, and you can run the software from there. So what we're going to do is use dynamic and joint parameters, because we're going to do the face bow as well as jaw movements. And now I'm going to go to start. So I have on the copy here, it says on the left side. So I'm going to go to my left side of condyle and record. I'm going to go over to the right. Record. Now I'm going to put the sensor and this is going to be a live preview. So I have a bite, I have the sensor, and you'll be able to see my movements. Now I'm going lateral left. All right. Protrusion. Opening. And now chewing. And that's it. So at this point, let me take off the face bow. At this point in the process, I can put the name of the patient, we'll just say Mo, and then save this as a PDF. And that file is now saved. So I'm going to show you what's bundled in that. So if I scroll here, I can look and go back and preview all the movements. And you see on the bottom, it's showing exactly what we're doing. Now I'm going to go into protrusion. We'll go into opening here in a second. And you can see I kind of tilt to the right. And now chewing. So if I view this, it looks okay. It's almost like checking a final before you let the patient go. Everything looks good. If I wanted to look at this in the tracks, I can take this off and have my tracings. What's exciting about this is, this normally would take hours to get all of this data. And if you look right here to the right, it took 26 seconds in order to calculate and present all of this data right here, 26 seconds. I can look at my parameters. To me, this, like I said, this is gold right here. Having these distances recorded that I can send, for example, if I'm the patient and we send this to a lab, and the lab can now program their articulator or put it in their virtual articulator. So let me switch this. So you'll have the patient, all the information here. I can scroll down. If this is the articulator you're using, of course, I'm on Verba, our Artex, which is one of the backbones of our company. But I look at this report and you see these numbers. Anything different than standard articulator settings will result in grinding, whether that be grinding in zirconia when you're checking this back on the articulator, or in the patient chair grinding on these units. And that's with no one doing anything wrong except for not having this data. So having this data allows me to actually copy the movements that I just did and make that adjustments, which is critical in design. And so I'm going to take the software, I'm going to take this data, and we're going to show an example. I have a sample case of how important having that extra data is. So if we look here again, if we just take a glance, my sagittal condyle inclination is completely different. So if we set my mouth on standard articulator settings and went through the movements and made a upper and lower all on four restoration, there would be a lot of grinding simply because of nature, just because of the way I open my mouth. So that's to me, that's very exciting, having this data now. And if you look here on the tracings, there's a lot of options, a lot of things we can do with this data. As far as research, if I'm making a splint, I could do these tracings before, make the splint, come back later on, see what's different. Do the same tracing and see what's changed. We'll see what affected that splint, what didn't. Do I need to make a change in the design? That's some of the research we're working with actually University of Texas, San Antonio, with Dr. Zimmerman. We're working on some of these features of taking this data and seeing how can we make things better. If we scroll down a little bit more, you can see how I showed a picture in the slides, how we can take this and mount this back on the articulator. So you can just see with different heights how different I am than if I mounted this, or if a brand new tech, mounted this in the lab and brought that to the ceramist and said, here's your mounting, seeing that tilted like that and at an angle, that person probably wouldn't be working there that long. But actually that's unique to me. That's my setup. So that result would be a lot more accurate. So not only ours, we have other articulators that we partner with. What's kind of cool about this is I can go to a SAM, for example, and then that data is now inputted in here that they can set up their articulator or set up their virtual articulator in whatever design system. So it's seamless in our system because it's our workflow. So what would happen was, you see where it says export to Ceramill, you would hit that button and that data would automatically go to our software. And so on that note, I'm going to open up our software and then show you what that looks like in actual design. All right, so we have a case here, just a single unit, but keep in mind, this is just a single unit. Imagine if I was doing a roundhouse or a 3-unit bridge. It's just the importance just grows exponentially because I have so many more contacts, so many more excursive movements to take an account for. And this is just one unit. So we're going to go into design. Once I move it from my other screen, 1 second. Okay. So the first thing we're going to do is line this up. So I'm going to match the intraoral scan with the bite that you saw earlier. So we have the bite, and then we have the actual scan that the doctor takes. And that's how we match the two together. I get a lot of questions of how do we take that sensor that you saw me use, and how do we match that up with the scans? And that first step I did is how we do that. Also, we have a digital representation of the bite plate. So we're going to lock in and match the two plates. And once I have that, let me show you this angle. So I'm going to go over here and I'm going to turn on the bite. So this particular case, this is where, you can pour this up, pour a model, and then here, this could have been a digital. It doesn't matter, but it being the same patient, it's going to match together. And now that movement is now tied to the upper and lower jaw. So I'm going to load jaw movement. So right now, it's taking all that data. And if you take a look at this while it's moving, it's a lot of information. So it takes a little while to load everything, because all those tracings, all those movements, all that is being brought over from one software to the other. So it takes a little while, relatively speaking. I mean, this to mount a case and weight on stone is still waiting a lot longer than what it's going to do right now. But what that actually is doing is now tying the upper and lower together with the bite, bringing all those movements in and analyzing that. So I'm going to take a second to look. I see we got a question. So Sean asked, can this data be exported to other CAD software like 3Shape, Exocad? Well, yes, we can transfer that data, the motion data, immediately into the software. But here's the exciting thing. Even if I'm designing in 3Shape, I can take those numbers and manually put those numbers in, and it's still that virtual articulator as if I had a custom guide tape. So it's not quite the same as jaw movement, but it's still much more accurate than, let's say, static. So we'll add this right now. So we have static occlusion, we have dynamic occlusion, and then we have jaw motion. 75% of CAD CAM still uses static occlusion, which is up and down. Dynamic is incorporating some form of virtual articulator, but usually that virtual articulator is standard, articulator settings, 30 degrees, 15 degrees, and you see in mine how off that would be. I'm not standard settings, so being able to take that data and manually input it into, let's say I had 3Shape with an AG articulator in there, that's just going to get me closer. So it's not locking anybody out, but for us, it's pressing a button and importing. Information is loaded, so I can go next. Let's move this off the screen really quick. I'm going to do a quick design. We'll just put a crown on there with some occlusion, and then we'll go to what I really wanted to show you. So I got a couple more. assume that margin's good. It's the beauty of webinars. We're not inserting this crown, but okay, so I'm gonna drop a crown in there. Let's move it up just a little bit. Okay, we'll go next. All right, so let's do. You know what? I don't want it to be too obvious. Let's drop these down a little bit. We'll make it a little more realistic. All right. So I'm going to bring in my articulator. Let's bring in the antagonist. And I'm going to drag this through. And I want you to see this movement right here. There's not a single articulator that can replicate that movement. And that's the chewing part that's being recorded. So let's take that off. We'll go back. So remember, we said static, dynamic, jaw movement. So I'm going to go to my adapt button, which is to cut my intersections. I'm going to go to static, and I'm going to hit static. So static, remember, up and down. I just removed my static contacts. So if I have a CAD/CAM system and I don't have virtual articulator, my tool I have is static occlusion removing. I just removed it. So if we look at dynamic, which incorporates jaw movement, and I hit the same button, all that extra grinding, let's undo that. All that extra grinding, it's not anything someone did wrong digitally. It's not having all the information available. So if you see that same wiggle that I showed you, let's go back and drag this. That cusp, that's the chewing function that's going to get that. So if you think about it, you know, when I was in the military, our labs are right there within the dental office. We're together, so the feedback was instant. So a lot of times I'm in the chair just seeing, you know, how a restoration we made, and it was all tap 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 was never a problem. You know what I mean? You put the paper, tap tap. It was always when you moved, not always, because I thought I was pretty decent, but when you moved in excursive, that's where that paper lit up that crown. And that's exactly what this is. And this, even if, like I said, if I had standard articulator settings, it's not going to get that last movement. It's not going to get that little zone to remove that data. So now take that and multiply that by however many units, if you're doing a roundhouse, if you're doing an all-on-4 restoration. That's a lot of grinding, unnecessary, especially on zirconia, when if you have that extra data, it just makes life a lot easier as far as finishing restorations. How am I looking? Where are we at on time? Ooh, 6:25. Okay, so really at that point, you know, that's kind of what the difference of this. I really wanted to drive home not just the technology and getting all that information. I wanted to show you guys on an actual case how that it can affect the restoration, how that can make it more accurate. So now I can make adjustments knowing I have that movement. Do we have any more questions?